Best MLDS Techniques 2024. So here we shall discuss the techniques which are used in top 10 research papers from MLDS or the Machine Learning Developer Summit Conference which held in Bengaluru in 2024. So let's get started. The first best paper was leveraging generative AI with transformers and stable diffusion for rich diverse dataset synthesis in EdTech by the company iMerit. Well, this paper addresses the challenge of data scarcity in agriculture technology by combining generative AI techniques with stable diffusion models for data synthesis. And the techniques that they used were LoRA or the low-rank adaptation of large language models. Well, LoRA is a technique which is used to adapt pre-trained language models to new task or domain while maintaining the efficiency and effectiveness of the original model. In simple terms, we can say it's a way to tailor a general purpose language model to perform better for a specific purpose, such as in agriculture. So imagine a pre-trained language model like a black canvas who is able to create artwork in various styles but not specialized in any particular one. So LoRa will allow you to paint additional knowledge and expertise onto that canvas, which will turn it into a specialized language model that excels in a particular domain. In agriculture, we can use the LoRa to adapt a large language model which is trained on generic agriculture information to perform specific tasks like crop identification, disease diagnosis, or even generating tailored recommendations for farmers. By fine-tuning the general purpose model with data specific to a particular crop or region, the resulting language model can provide more accurate and relevant information for farmers. Ultimately, it shall benefit the agriculture industry. So to summarize this, we can say LoRa is a powerful technique for customizing large language models to specific domains or tasks which enable them to provide more accurate and relevant information for practical applications like agriculture. The next technique that they used was DINOv2. Well, DINOv2 is an advanced self-supervised learning technique to train models by accurately identifying individual objects within images or video frames. So in case of agriculture, this DINOv2 can be used to train models that will accurately identify individual crops, detect pests, and diagnose the plant diseases, which will provide farmers with a more valuable information to make informed decisions about their crop. The next technique that they used was a stable diffusion. Well, stable diffusion is a technique that helps create realistic images based on the text description. So imagine using text prompts like a healthy tomato plant with the red ripe tomatoes to generate an image of a tomato plant with detailed convincing tomatoes. So in the context of agriculture, the stable diffusion can be used to create visualization of crops, predict crop growth and yield, and even simulate various agriculture practices to help farmers make informed decisions. The next paper was PII detection in the emails through LoRa fine-tuned LLM, a comparative analysis with the BERT and GPT-3 by the company Genpact. Well, this paper explores the use of LLMs, fine-tuned LLMs for detecting and masking PII or the personal identifiable information. It helps in enhancing data security and ensuring domain adaptability. And the techniques that they used was Vicuna 7B. Well, this Vicuna 7B is a machine learning model which is designed for natural language processing tasks such as detecting personal identifiable information in tasks. So this PII or the personal identification information refers to any information that can be used to identify a specific individual such as name, address or social security number. So using Vicuna 7B helps us to identify PII or the personal identifiable information in text by analyzing the input and flagging specific words, phrases or sentences that match patterns associated with personal identifiable information. So imagine you receive an email which contains personal information such as your address and phone number. So using this Vicuna 7B, you can train a model to analyze the email content and detect this personal identifiable information, which will allow you to protect the sensitive information before forwarding the email to someone else or storing it in a database. So here in this paper, they used fine-tuned Vicuna with the LoRa technique. Now this LoRa technique is a process that enhances the performance of Vicuna 7B model for specific tasks such as detecting personal identifiable information in emails. So fine-tuning will involve adjusting the pre-trained Vicuna 7B model to better recognize patterns and features which are relevant to the specific task at hand. So in the case of personal identifiable information detection in emails, fine-tuning with LoRA will involve training the Vicuna 7B model on a dataset of labeled emails containing PII so that it becomes more adept at identifying this PII in email content. Now this CLORA or the quantized low rank adaptation is a technique that helps reduce the computational cost of fine-tuning while maintaining high accuracy. So by fine-tuning this Vicuna 7B with the CLORA for personal identifiable information detection in emails, you can create a customized model that can accurately identify sensitive information in emails, which allows you to protect and secure your personal data. Now they compared the results with the BERT or the bidirectional encoder representation from transformers, which is a powerful natural language processing technique used to analyze and understand the written text. Well, BERT allows computers to read and comprehend sentences and paragraphs much like humans. Now, in the context of personal identifiable information, this BERT can be used to analyze the content of email and identify patterns associated with personal identifiable information such as name, address, and phone number. So by using this BERT, you can develop an NLP based system that can automatically detect the personal identifiable information in emails, which will allow you to protect and secure sensitive information. For example, you can train a BERT-based model on a data set of labeled images which contain this personal identifiable information. So once trained, the model can be used to analyze the new incoming emails and highlight or mask any personal identifiable information it identifies, which helps you to maintain the privacy and security of your personal data. Then they compared the results with GPT 3.5. Now this GPT or the generative pre-trained transformer is a powerful language model that can generate human-like text based on the input it receives. So imagine a language generating machine that can write essays, compose songs, or even craft emails on your behalf. So for example, you can provide GPT 3.5 with a topic and it will generate a coherent and well-written essay on that subject. You can also ask GPT 3.5 to rephrase a sentence, translate text between languages, or even compose a tweet. So its wide range of applications makes it a valuable tool for various industries, including marketing, content creation, and customer service. The next paper in this category is Enhancing Investment Committee Decision with LLM Powered Q&A Assistance, Best Practices for Building LLM Powered Enterprise Knowledge Retrievals by the company Walters. Well, this paper examines the application of large language models in enhancing the efficiency and accuracy of investment decision making within firms. And this paper utilized large language models. Now, what are large language models? They are advanced computer programs that can understand, interpret, and generate human-like text. They are called large because they are trained on vast amount of text data, often billions of words or more. So in the context of investment decision making within firms, LLMs can help in various ways. So imagine you are an investment analyst who is tasked with analyzing a potential investment opportunity. So traditionally you will spend a significant amount of time manually reviewing data from various sources such as company reports, financial statement, market trends, and industry news. But with the LLMs, you can input all of these resources and then can ask the model questions or provide it with a prompt. So the model can quickly analyze that information and will generate the response that provides insights, answer your question, and even draft a preliminary investment memos, which helps you make informed decision faster and more accurately. For example, an LLM can be trained on a vast corpus of investment memos and market research reports. So you could feed it the data room documents for a potential investment target and ask it to generate an initial investment hypothesis. So the LLM would analyze that information, will identify key factors such as the target market position, growth potential, and financial performance, and then will produce a well-structured hypothesis on the investment potential. So these LLMs can help you quickly answer questions that might arise during the investment decision making process. For instance, you can ask an LLM to compare the target company's financial performance with its peers or provide a summary of recent industry trends affecting the target's market. So to summarize this, we can say that LLMs can enhance the efficiency and accuracy of investment decision making within firms by providing rapid, well-informed decision and insights that can help analysts make better informed investment decisions more efficiently. The next paper in this category is Breaking the Language Barrier, Natural Language to SQL using Large Language Models by the company DINOv2. Well, this paper describes a chatbot interface that uses a large language model NSQL350 to convert this natural language queries into SQL commands for retrieving and analyzing specific data from retail media campaigns. Well, it enables non-technical media planners to ask the chatbot questions about their data in English, and then the chatbot will translate that questions into an SQL query, which is executed on the database to retrieve the necessary information. And this paper focuses on the process of fine-tuning the language model and its accuracy and highlights potential applications for retail media campaign. The main idea is to provide media planners with an easy to use tool for understanding and analyzing their historical campaign data in a more efficient way. And the techniques that they used was NSQL 350M. Now this NSQL 350M is a large language model that has been specifically trained on the diverse set of text, including natural language queries and their corresponding SQL queries. So in simple terms, it is a computer program that can understand and generate text specifically in the context of translating natural language queries into the SQL queries. And in the context of this discussed retail media campaign domain, NSQL 350M can be used to build a chatbot that can answer questions about the data in campaign. For instance, a user might ask what was the total sales revenue for product A last month. So here the NSQL 350M LLM can process this question, will understand the relevant data requirements and then generate appropriate SQL queries such as select some revenue from transactions where product ID is A and date between 1st March 2022 to 31st March 2022. So this SQL query can then be executed to retrieve the required data from the campaign's database, and the chatbot can provide the answers to the users. Well, NSQL 350M's strength lies in its ability to process large amount of text data and its ability to learn from the patterns and relations it finds in its data. So by being specifically trained on natural language queries and SQL queries, NSQL 350M can effectively translate this natural language questions into SQL queries, which makes it a valuable tool for building chatbots that can assist users in navigating and understanding large data sets. The next technique that they used was fine-tuning LLM. Now this fine-tuning will involve taking a pre-trained LLM like NSQL 350M and further training it on the task-specific dataset. For example, in the retail media campaign domain, fine-tuning might involve training NSQL 350M on a dataset of natural language queries and their corresponding SQL queries related to retail media campaign. So this additional training allows the LLM to better understand the specific context and improve its ability to generate accurate SQL queries for that domain. So imagine a chef using a pre-trained recipe book and then fine-tuning it by adding more recipes specific to Indian cuisine. So this refined recipe would now be better suited for generating Indian cuisine recipes. The next technique that they used was prompt engineering. Well, prompt engineering is the art of crafting the input given to LLM to guide it towards generating the desired output. Basically, it involves designing the input queries in a specific way to ensure that LLM generate relevant and accurate response. For instance, a prompt might be designed to start with a particular structure like given the following data, the SQL query to retrieve is this, right? Now this structure will help the LLM understand the task at hand and produce a more accurate SQL query. So consider a language learner using a pre-trained translation tool. So here the prompt engineering will involve structuring the input sentences in a way that guides the tool to provide correct translation. The next paper in this category was Mitigating Hallucination in Foundational Language Models, a structured approach for hallucination-free query responses in regulatory domains by the company Tridence. Well, this paper tackles the challenges which is faced by the foundational models, particularly GPT's issue with generating incorrect yet plausible responses, that is hallucinations. So for this, the authors proposed a solution which leverage a structured approach using a knowledge-based in formats like PDF, HTML and Word doc. And that solution involves implementing techniques like RAG or the retriever augmented generation, prompt engineering and post-processing in a production-grade query bot application. So additionally, this paper describes a scoring mechanism for determining the accuracy of the generated response when multiple passages are provided in the text. And then this implementation of this solution results in a significant business impact, which is including a 150% improvement in its response time, enabling status tracking and enhancing the user experience. And this paper concludes by emphasizing the effectiveness of proposed structure, which includes prompt engineering, post-processing and a scoring mechanism to address hallucinations. And the techniques that they used was RAG or the retriever augmented generation. Now this RAG is a technique which is used in natural language processing to improve the quality of text generation. It involves two methods, retrieval and generation. Now this retrieval means the process of finding the most relevant information from the large database, while generation refers to creating new text based on that information. So in this discussed domain, RAG is used in a query bot application to answer user queries. So whenever a user asks the question, RAG process would work like this. The first step is to search a predefined knowledge base, that can be PDF, HTML or the Word document, for information related to the user's query. And then this knowledge base contains a vast amount of relevant data that has been pre-processed and indexed. So once that system finds the most relevant document, it will extract the passages, that is a small piece of text that best match the query. And these passages are ranked by their relevance to the query. The second part of the RAG is the text generation. Well, here the system will use a language model like GPT to extract a response based on that extracted passages. So however, the GPT model is retrieved augmented, since it is provided with the relevant passages from the knowledge base instead of generating the response solely from its own training data. So by incorporating information from the relevant passages, RAG approach will help ensure the generated response is accurate and informative. For example, let us say a user asks the query bot, what is the maximum speed limit on a highway in the USA? So the RAG process would search the knowledge base for relevant information, will find a passage from a government website that specifies the maximum speed limit is 70 mph, extract that passage and feed it to the GPT model. Now this GPT model would then generate a response which will incorporate those extracted information and will ensure that the answer is accurate and specific to the USA. The next technique that they used was prompt engineering. Now this prompt engineering is the process of designing the input text or the prompts given to a language model. This involves carefully choosing and arranging words, phrases and formatting to guide the model towards generating high quality and accurate responses. So by crafting effective prompts, you can improve the output of language model and can increase the relevance and effectiveness of the generated text. Also, they used post-processing, which involves applying techniques after a language model generates a response, which can include filtering, fact-checking, paraphrasing, or selecting the most accurate response from the set of candidates. Then they used scoring mechanism, which means it assigns a numerical score to each generated response based on factors like accuracy, relevance, and fluency. And these scores are used to rank responses and select the best one for the final output. Then the next paper was Enhancing Text Pair Risk Prediction through LLM Driven Profile Tuning by Government of Andhra Pradesh. So the governments around the world need to identify potential issues with the taxpayer financial records, and this research introduces a new way to use powerful AI systems called large language models to analyze taxpayer data. So by doing this, the AI can better understand how taxpayers behave and predict if there are any potential problems. which will involve accuracy and providing more detailed information. And the techniques that they used was natural language generation. Now, this natural language generation is a process of creating human-like text using this artificial intelligence. So, in simple terms, it's a AI-generated text that reads as if written by a human. So, natural language generation can be thought of as a text generation part of large language models. And in this discussed domain, NLG is used to generate comprehensive natural language profiles for each taxpayer. Now, these profiles will describe a taxpayer's financial behavior and history in a human-like manner, which makes it easier for financial analysts to understand and analyze the data. For example, the natural language generation generated profile might say something like this, that this taxpayer has a history of making timely payments and consistently declaring a steady income. So their transaction shows no sign of suspicious activity or irregularity. And this profile generated using natural language generation provides a clear and easy understandable summary of the taxpayer's financial behavior, which can be used to make informed risk assessment. The next technique that they used was fine-tuning LLM. So fine-tuning a LLM is a process of customizing an already trained AI model to better perform a specific task, such as risk assessment. So it's like training the painter or the LLM to paint a specific type of picture, that is risk assessment. So in this discussed domain, a pre-trained LLM like GPT-3 is fine-tuned to better predict taxpayer risk. And this fine-tuning process will involve providing the LLM with large set of text pair profiles, which is generated using natural language generation, and their corresponding risk scores, which is calculated using traditional methods. So by doing so, LLM learns to associate specific financial traits and patterns with the likelihood of taxpayer being risky. For example, let us say the pre-trained LLM is initially good at predicting risk based on taxpayers' income and payment history. So by fine-tuning it using a dataset of taxpayer profiles and their corresponding risk scores, the LLM learned to make even more accurate prediction by considering additional factors such as frequency of transactions, the diversity of payment methods, and more. So to summarize this, we can say that fine-tuning LLM allows the model to adapt to specific tasks, which make it more proficient at risk management than a general purpose pre-trained LLM. Then the next paper in this category was enhancing zero-shot image classification, a tried approach with prompt refinement, confidence, calibration, and ensembling by the company Ekidata. Well, in the field of computer vision, accurately classifying images without prior training is a difficult task. And this paper introduces a new technique that improves the ability of a specific AI system or the clip to label images without the need for label data. So by doing so, they are able to achieve better results in zero-shot image classification, which means a system can correctly classify images it has never seen before without any additional training. And the technique that they used was CLIP, or the contrastive language image pre-training. Now this CLIP is a method for training a powerful AI model to associate image and text. It's like training a language model to understand the relation between the words and images so that it can perform tasks like identifying objects in images or describing them in words. So in this discussed domain, CLIP is used to pre-train a model on a large dataset which contains both images and their corresponding captions or the textual descriptions. And this pre-training helps the model learn the connections between images and the words used to describe them. For example, when training CLIP on a dataset with the image of dog and a text a cute puppy, model will learn to associate the image of dog with the word dog, right? This understanding allows CLIP to perform tasks like image classification, that is identifying the objects in image, and image text retrieval, or finding images that best match a given text description. Then the next technique that they used was ensemble learning, which was combining inductive biases of CLIP and DINOv2. Now this ensemble learning is a technique that combines the prediction of multiple models to achieve better results than using a single model. And in this research, the authors combined two pre-existing models. First was CLIP and second was DINOv2 for image and text understanding. And in this discussed domain, the authors used ensemble learning to improve the task of zero-shot image classification. So by combining the strength of both CLIP and DINOv2, the ensemble models can better identify and classify images despite having never seen them before in its training data. For example, imagine you have two expert friends, Alice and Bob, who both are great at identifying birds. And you show them an image of bird you found in a new location. And both Alice and Bob will provide you a prediction, that is the name of the bird. So by taking an average of their prediction, you can create a more accurate and confident final identification, which will benefit from the individual expertise of both Alice and Bob. So in this case, the ensemble model combines the inductive biases or the learned patterns of CLIP and DINOv2 to provide more accurate and confident zero-shot image classification. Then the next technique that they used was prompt refinement using a language model, that is GPT 3.5 Turbo. Now this prompt refinement is a technique which is used to improve the performance of model by refining the way it receives input. In the case of this research, the authors used a language model, that is GPT 3.5 Turbo, to generate more descriptive prompts for the main model, that is the CLIP here. Now this prompt is a short text which is used to guide the model's understanding of the task at hand. So by refining these prompts, the model can better understand the relations between the images and their associated text description, which leads to improved performance in tasks like image classification. And in this discussed domain, this GPT 3.5 Turbo is employed to create more informative and precise prompts for the CLIP model. For example, consider the task of identifying animals in images. So with the prompt refinement, the original prompt, that is describe the animal in image, can be refined to this image depicts a specific animal which is characterized by its, say, key features. Now this refined prompt will provide more relevant information to the CLIP model, which will enable it to do better understand the image and its associated text description. So this application of prompt refinement in the discussed domain leads to improved zero-shot image classification performance without requiring any additional training data. And this technique is particularly useful when you are working with few-shot or the zero-shot learning scenarios. Then the next technique or the next paper in this category is design of reward functions for multi-objective adaptive cruise control using deep reinforcement learning by the company Renault Nissan. Well, adaptive cruise control or ACC is a technology that helps maintain a safe distance from the vehicle in front while driving. And this research investigates the use of specific type of AI, that is the deep reinforcement learning, to improve this ACC or the adaptive cruise control system. So by doing this, they found that ACC system controlled by deep reinforcement learning performs better than the traditional method, which results in a safer driving experience. And the technique that they used was deep reinforcement learning, which is a combination of two powerful techniques, that is deep learning and the reinforcement learning. So imagine a self-driving car that needs to learn how to drive safely and efficiently. So here this deep reinforcement learning can be used to teach this car how to behave by providing it with a feedback on its actions. So in deep reinforcement learning, an artificial neural network or a type of deep learning model is used to make decisions, and reinforcement learning is employed to learn from the consequences of those decisions. So the neural part will act as a policy that will determine the actions that self-driving car will take based on that information that it receives from the sensors. So this self-driving car is placed in a simulated environment where it interacts with its surroundings by making decisions such as accelerating, braking, or changing lanes. And after each action, this car receives a reward which can be positive or negative that indicates whether its action was successful or not. So this reinforcement learning part of deep reinforcement learning updates the neural network policy based on that received rewards. And over time, the network learns which action leads to higher rewards and it improves its driving performance. So in this discussed domain, deep reinforcement learning is used to control a battery electric vehicle's acceleration and braking in a ACC or the adaptive cruise control system. So this deep reinforcement learning controller will learn to make optimal decisions, balancing driving objectives like tracking, accuracy, safety, and ride comfort. Now what this ACC is, to understand this, this diagram will help you understand it better. Right. Now this ACC is an advanced driver assistance system that helps maintain a safe following distance while driving at a set speed. It is designed to make long distance driving more comfortable, safer and less tiring. And in this context of discussed domain, ACC is used for battery electric vehicle. And the system uses sensors such as radar, lidar or cameras to monitor the surrounding traffic, detect the position and the speed of the vehicle in front of BEV. So when this ACC is activated, the driver sets a desired cruising speed and the desired following distance, and then the ACC will take control of vehicle's acceleration and braking, will maintain the set speed, adjusting the distance from the vehicle in front. So if the vehicle in front slows down, ACC will also slow down the BEV to maintain that preset following distance. So if the road ahead is clear and there are no vehicles in front, then ACC will return the vehicle to the set speed. So in simple terms, we can say that this ACC helps the driver maintain a safe following distance and speed without the driver having to manually adjust the vehicle's speed and distance, making long drives more comfortable and less tiring. Then the next paper in this category was revolutionizing market surveys through unprecedented generative AI for efficient data synthesis by the company Course 5i. Well, these traditional market research methods have issues like delayed results and responses that may not be accurate. So this research presents a new approach which combines AI system, that is the generative pre-trained transformer, and multiple language models to improve this market survey practices. And this innovative method speeds up the survey process and allows for more personalized interactions, which enhances the overall research experience. And the techniques that they use were GPT, or the generative pre-trained transformers. Now this GPT are a type of advanced language model that has been trained on a vast amount of text data such as books, articles and social media posts. And think of it like a very intelligent and well-read language expert who has read almost everything. So in this discussed domain of market survey analysis, this GPT can be used to generate synthetic data, which is data that mimics real world survey responses. And this data can be used to test hypotheses, develop new insights and create targeted marketing campaign. For example, imagine you are a marketer who is trying to design a survey for new product launch. So instead of sending the survey to real people, you can use a GPT to generate synthetic responses based on the patterns and trends that it has learned from vast amount of text data, which will allow you to quickly create a large and diverse data set without the time and cost of recruiting human participants. In short, we can say that these GPTs are like a language expert that generate text based on what it has learned from the vast raw information, which enables researchers to create synthetic data for market surveys more efficiently and cost effectively. Then the next technique that they used was ensemble language model. Now this ensemble language model are a collection of multiple pre-trained language models that work together to generate text. So imagine an ensemble language model as a group of expert language models, each have its own unique set of strength and knowledge. So by combining their abilities, the group can provide better and more accurate response than a single model could do alone. So in the context of this discussed domain, ensemble large language models are used to enhance the quality of synthetic data which is generated from GPT. And by using multiple language models, the ensemble LLM can capture the wider range of language patterns and which results in synthetic data more accurately, right? And that closely resembles its real world survey responses. For example, let us say you are a researcher who is designing a market survey on customer preference for a new product. So by using an ensemble LLM, you can combine the expertise of several language models to generate a diverse set of synthetic responses that reflects the opinion of different demographic groups, geographical regions and cultural backgrounds, which will enable you to create a rich and representative data set without having to conduct a large scale survey with real people. So to summarize this, we can say that this ensemble LLM are a powerful tool that combines the strength of multiple language models to generate high quality synthetic data for market surveys, which provides a more accurate representation of real world responses and enables more informed decision making. Then the next paper in this category was revolutionizing energy trading, advancing the energy market with a cutting edge conversational generative AI powered forecasting tool by the company GenAI. We know that Indian Energy Exchange is an important platform in India's energy market, which helps to buy and sell electricity. And this research introduces a new tool that uses historical data and advanced AI techniques to forecast this electricity prices for the next 7 days. So this tool will allow users to ask questions, generate reports, which makes the process more user friendly and efficient. And the techniques that they used was time series forecasting. So this time series forecasting is a technique which is used to predict future values based on the historical data recorded over time. In the context of this electricity domain, it involves predicting future electricity prices using historical pricing data. So imagine you have a data set of electricity prices for the past few years. So this time series forecasting would analyze these historical prices to identify patterns, trends, and seasonality such as daily, weekly, and yearly fluctuation. And based on this analysis, the forecasting algorithm would generate predictions for the next 7 days. For example, imagine the electricity price on Monday of week 1 was high due to increased demand. Now, this time series forecasting algorithm would recognize this pattern and will use it to predict that the price on Monday of week 2 would also be high. So, by analyzing historical data and identifying such patterns, time series forecasting can help provide accurate predictions for future electricity prices. Then the next technique that they used was GenAI models. So this generative AI model is a type of AI system that generates new content or response based on the patterns that it has learned from the large data set. And in this context of electricity domain, the Gen AI is designed to generate natural language responses to the user queries about electricity pricing. So imagine you have a tool that can answer questions about the electricity prices. And this tool has been trained on a vast amount of historical electricity pricing data and has learned the relations between different factors that affect the price, such as demand, supply, and weather. So whenever a user asks a question about the future electricity prices, this Gen AI model will use its understanding of historical data to generate a response in natural language that will provide an answer to the user's question. For example, a user might ask what will be the average electricity price for the next week. So here this Gen AI model would use its training to analyze the historical pricing data, will identify patterns, and then will provide an answer in the natural language, such as based on our analysis, we predict the average electricity price for the next week to be around 5.2 Indian rupee per kilowatt hour. And the next technique that they used was natural language processing. Now this NLP is a branch of AI that focuses on enabling computers to understand, interpret, and generate human language. In simple terms, this NLP enables computer to talk, listen, and understand humans in a way that feels natural. And in the context of electricity domain, NLP is used to enable the Gen AI model to understand and interpret natural language queries which is related to electricity pricing. For example, a user might ask a question like, what shall be the price of electricity in the Delhi region next month? So this NLP component of system would process this query, will identify the relevant information, that is the reason and time frame, and then it will pass it to the Gen AI model to generate an appropriate response. So by using NLP, the system can interact with its users in a way that feels intuitive and natural, which allows users to ask questions in their own words rather than having to navigate through menus or input data in a predefined format, which makes the system more user friendly and accessible to the wide range of users. Thank you.